All right, let's start chapter 10. Parabolas, conic sections. So I encourage you to look at 10.1, which is all of one page, because there were some really cool, there's really cool visuals, computer generated visuals that show you where conic sections come from. They're actually cross sections of cones. That's why they're called conic sections. So let's start with parabolas. We all know about parabolas. Y equals x squared is one of the functions in our family of functions that we memorize and shift around and stretch and all of that stuff. We're going to look at parabolas in the form y equals x squared, but we're also going to look at parabolas in the form x equals y squared. So let's keep it simple. Always pause me, right? You guys know that I don't have to say that anymore. Write this down and let's start with simple, vertex at 0, 0. So, vertex at 0, 0, all of them are going to go through the origin, every single one of them. We can have opening to the side, to the right. We can have opening to the left, opening up, and opening down. And maybe in later math classes, you'll talk about parabolas that open along a diagonal. Not in this one. There is a section in our book, but we don't talk about it. The point along the axis of symmetry, right? We know the axis of symmetry. So for both of these, the axis of symmetry is the x-axis. For both of these, it's the y-axis. The point on the parabola that falls on the axis of symmetry is called the vertex. And then there's a couple other things that we want to look at. We want to look at the focus. The focus is always inside of the parabola. I'm just estimating where it might be on these. We'll talk more about the actual placement of the focus later. And then the directrix. The directrix is a line that is perpendicular to the axis of symmetry. Perpendicular to the axis of symmetry. So this one's going to go this way because the axis of symmetry is the y-axis on these two. So the directrix is there. Okay. For parabolas with the vertex at the origin, we could write the equations of the directrixes. Okay, if we were in class, we would try and figure out how to pluralize that, but we're not, so. And then we could also write the points, the focal points, the ordered pair for the foci, but I don't want you to worry about memorizing that stuff, so I'm not going to write that down, okay? But we do need to pay attention to the equations. So these are opening left and right. We're used to seeing y equals x squared that looks like this, right? And this would be like y equals negative x squared, or some variation of that. So I know that opening up down has the x squared. Therefore, opening left right must have the y squared. And the form that we talk about in this chapter is a little different than what we're used to when we talk about all those parent functions. The squared term is on the left instead of the right. Notice that here the equation is the same for both of these. But when it opens to the right, we know that A is positive, and when it opens to the left, we know that A is negative. And that kind of makes sense, right? The positive x-axis is to the right, positive A value. The negative x-axis is to the left, negative A value. Okay? So this form is going to mimic exactly this form, except it's going to be switched. Okay, and then the same thing is going to be true. Opening up means A is positive. Opening down means A is negative. Oops, sorry, you can't see that. Okay? All right, so what is A? This thing in this equation, what does that A represent? Let's talk about that. So if you need a second, go ahead and pause to make sure you have this all written down. Sorry again about the shadow. It's my fun Saturday night. It's not light outside, so there's no sunlight coming in this way. It's all coming from above. Okay. A is the distance from the vertex to the focus. A is the distance from the vertex to the focus. A is called the focal length. Why did I just write fold? Called, I was talking about the focal length, and I wrote an F when I didn't mean to. A is called the focal length. It is the distance from the vertex to the focus. Another interesting fact about parabolas is that distance is also the same as that distance. So if we were in class right now, I'm starting to be sad again that we're not in class. If we were in class right now, we would do this really cool activity on Desmos or on paper. I have actually 2 different activities that would show you the definition of a parabola is actually that the distance from the focus to any point on the curve is the same as the distance from that point to the directrix. So first thing, when we're talking about distance from a point to a line, we're going to go perpendicular. So let me show you what I mean. This is not huge and important. This is not something that's going to come up on a quiz or a test, but I do want you to understand it, okay? So I'm just going to pick a random point on the curve, and I'm going to illustrate the distance from that point to the focus and the distance from that point to the directrix going straight down, perpendicular. These 2 lengths are the same no matter where I put that point. I could put that point way over here. The distance from point to focus is the same as the distance from point to directrix. So any point on the parabola, it doesn't matter where I go. If I illustrate the distance from that point to the focus, it is the same as that point to the directrix. So then obviously this distance from the point, which is just happens to be the vertex, right? The distance from the point to the focus is the same as the distance from the point to the directrix, okay? Okay, and then when we have the vertex at something that's not 0, 0, we need to write it in vertex form. These are also vertex form, it's just that the vertex is 0, 0. If you look, if you plug in a 0, 0 for HK here, you'll get this equation. And if you plug a 0, 0 for HK here, you'll get this equation up here, okay? So this is really all you need to memorize here. You don't need to memorize all 4 of those. Those will happen organically if you plug in a 0, 0. And then the same is true for the up down. If A is greater than 0, then it opens up. If A is less than 0, then it opens down. And here, if A is greater than 0, okay, I want you to think about that. Don't look at your graphs. Which would be the positive direction? Opens right. And if A is less than 0, then obviously the only thing that's left is left. Okay? All right, so let's do some actual problems here. So find the equation of the parabola with focus at 4, 0 and vertex at 0, 0. So the steps that we're going to do these problems in are pretty much always the same. First thing is we're going to draw a picture. So if you feel like you don't remember stuff very well, maybe pause me as I'm saying it and write steps off to the side. So number 1 would be draw a picture. Over 4 up 0, that is the focus, and 0, 0 is the vertex. Determine which direction it opens. That would be step 2. Which direction does it open? So now the focus has to be inside of the parabola, so it can't open to the right. It can't open up. I can't show you. Here, I'll just do this. It can't open up. It has to go through the vertex, right? The vertex is the point along the axis of symmetry. It can't open to the right. It can't open down. The focus has to be inside, so it opens to the right. The next thing I'm going to do is find the value of A. So if you're writing down steps, we're going to find the value of A. Well, remember, A is the distance from the vertex to the focus. We can figure that out right here. A is the distance from the vertex to the focus. That's 4 units. 1, 2, 3, 4. Okay. Step 4, is it going to have an x squared or is it going to have a y squared? We'll go back up here. If it opens right, it's going to have a y squared. Okay, so it's going to be of the form there. And then the last step is just to plug stuff in. Plug everything in. We know the vertex is 0, 0. This is our HK. Let me see. Can I do this with different colors? I think I can. Let's do it this way. This is our HK. That's the vertex. So I'm going to plug the H. The 0 is going to go there. K, the 0 is going to go there. And then I found the A because I remembered this definition up here. That's going to be a 4. So I'm just going to write out what I have. Y minus 0 squared equals, this is what's happening with this 4 and this A here. What are they doing to each other? Okay, hopefully you said multiplying. So 4 times A, so 4 times A, and then x minus 0. That's your equation. Now I feel like asking, does anyone have any questions? But there's nobody here with me. Ugh, this is so sad. Okay, last example. Are we ready? Write that down. Pause me for a sec. Okay, so step 1, remember, draw a picture. I need to think what I'm going to be doing. I'm going to be going in the negative direction on the y-axis and the positive direction on the x-axis. So over 2 and then down, the lowest is negative 5. So the vertex is 2, negative 3. The focus is 2, negative 5. So I want you to figure out which direction it opens. Okay, so hopefully you figured out it opens down. Because again, if I open up, open left, open right, the focus is not on the inside. The focus needs to be on the inside. Okay? Next thing I want you to do is find the value of A. Okay, hopefully you got A equals 2. From here to here is 1, 2 units, right? My picture isn't perfect because it's not on graph paper. I would recommend graph paper for this assignment because I think you're going to be doing some graphing. I mean, you're definitely going to be drawing these pictures, but I think you're also going to be doing some graphing. All right, next question. Is it going to have x squared or is it going to have y squared? Figure that out real fast. So opens down is going to have x squared. And hopefully you remember that because we've been studying y equals x squared parabolas quite a bit. Y equals x squared, y equals negative x squared. Yeah? So it's going to be the equation that has x squared. And then again, we're just going to plug all of our stuff in. So the vertex is the h comma k. So the h is 2. The k is negative 3, and then the a is 2. So we have x minus 2 squared equals, remember the 4 is being multiplied by a, 4 times a, so 4 times 2 is 8. Now y minus negative 3, keep that in mind because if I give you an equation and I ask you for the vertex, you need to remember that the general equation has y minus. So the way that it turns into a plus is that the h or the k, whatever we're looking at, is a negative. Okay? And then one more thing I want to point out. Notice here that the h is always stuck with the x. And the k is always stuck with the y. Because that's the x coordinate of the vertex and the y coordinate of the vertex. So the x coordinate of the vertex is always going to be connected with the x, and the y coordinate of the vertex is always going to be connected with the y. Woo, made it under 15, barely. Hope you guys are doing well.